Hey everyone, welcome back to the channel. Today I want to wish everyone a happy Thanksgiving, but also I just want to say thank you for everyone who subscribed. We just finally broke the 200 mark, which I know for a lot of people is very little, but for me that kind of feels like an accomplishment. So stay tuned here. Hopefully you enjoy this video. We're going to go into a small dive into Fusion 360, specifically about adding bits, sizes, and figuring out your feeds and speeds. So stay tuned and thanks for watching. So today I want to go over something that I saw in the comments, and to be honest with you, I think everyone needs to kind of understand speeds and feeds for your operations. Something that I've always struggled with, even myself, is trying to figure out that optimal load for the machine at hand. I've owned a few machines over the years, and one thing that definitely comes up more and more is, hey, how fast do you run your tool? What's your rotations? Your RPM. What's your feed rates? How fast can you cut this type of material? So I'm going to show you what I do when trying to figure that one out and go from there. So one thing that I want to bring up first is I actually like to use a company called Onsrud. They are a manufacturer of end mills, and they actually have a lot of good information regarding all the tools that they end up using. So for this, we're going to just go ahead and pick a 4100 series 101. It's an 1/8 inch end mill because a lot of desktop CNCs actually use 1/8 inch tooling. And yeah, so let's go ahead and get started. I'm going to go ahead and go to the Onsrud page and actually pull up the 4101 just for a test. And it basically tells you you can use it for softwood, hardwood, or aluminum sheet. So in this case, we're going to just assume we're going to do let's say a hardwood, for example, because a lot of desktop machines will use a hardwood. Okay, so on Onsrud's website, you can actually go ahead and Google search a cutting data recommendations from LMT Onsrud, and they give you these little aluminum composites, drilling foam, hard plastics, and in this case we're doing hardwood. And so I just went ahead and pulled up the data record that they have for their bits, recommended chip load per tooth by cutting diameter in inches. And in this case, we're going to be using a 1/8 inch end mill. And we have the 4100 series bit, and it's going to tell us this is the recommended chip load that we should be using. Something to note here, they do give you the chip load feed rates calculations here at the bottom in case, but we're going to go ahead and use Fusion 360 to help us kind of calculate that out. So based on these chip loads, we're going to say that we're going to try to, basically determine what our machine is going to be using, and then as well as, since the chip load is given, then Fusion 360 will tell us what our feed rates are at the end. So let's go ahead, go back into Fusion 360 here, and this is the part that I want to do. So if you remember from the previous one, we have to first set up our material, and once we're in the setup, we'll go here into the stock material, and in this case I just want to mill out this pocket. So you can see how it's kind of overlapped the box. We're going to go ahead and change that real quick. We're going to say from solid, we're going to click on our solid, and now our cutting box is the actual solid itself. We're going to go back to setup, and we're going to pick a machine point, which is normally what I like to do is pick the top corner because that's where I'm going to zero my machine out. And then as for orientation, just make note if you do need to change that. So as of right now, my Y and X and Z are in the wrong coordinate system. So we're going to go back here and we're going to try to flip the orientation. So we're going to pick the X and Y axis because that makes life easy. So this is my X axis, this is my Y, and my Z is now in the opposite direction. I'll just click on Z, and it was supposed to just flip it as easy as that was, but that did not work. So there we go. X, Y, and Z. I'm going to end up picking my stock point as the top again. And there, I just want the Z going in the up direction. My X and Y, obviously you can flip and rotate and play with that as need be. I'm going to go ahead and hit OK. And there we go. So now you're saying, okay, well, how do I input my tool that I want to use? So in this case, we're using that Onsrud 1/8 inch bit. And that's where we have to then go into our tool library. So what we're going to do is go into Manage, Tool Library, open that up. Inside of here, you'll see a little plus sign at the top. We're going to have to click into one of these. So I'm just going to go ahead and click Library, for example. And you'll see the blue plus sign has been added. If you're in the All category, you'll see it's grayed out. That just means you need to drop into one of the subcategories in order to add it. So we're going to go all the way into our library and click the plus sign. So this bit for this purpose is a flat end mill, 1/8 inch diameter. Length of cutter is 3/8 of an inch. The shank diameter, which is past the cutter, is 1/4 inch. Our overall length is 2 5/8 inches. And a lot of times people don't realize it, but you want the helix direction normally when you're milling items is to come up, because what that does is it pulls the chips away from your material. There are some instances where you want to use the helix direction going down, but for a home hobbyist, just make sure that you pick the up direction. In this case, it'll have 2 flutes. If you can afford to get a higher number of flutes, it is recommended. Because then your chip load, you can spin the RPM faster. So obviously less flutes, less RPMs, and you'll see that in the demonstration here, hopefully. So here we go. We have a flat end mill, and we'll go ahead and pick that. And we'll just call this Onsrud 40101, which I believe was the tool name. So let's just double check. 40101. And for this case, we're actually going to call it hardwood. The reason why we want to at least call it hardwood is because there's different chip loads for different types of materials with their data sheets. So a lot of vendors have these data sheets. It's just a matter of finding them. And especially a reputable manufacturer of end mills, they'll have that information for you. So we'll go here to cutter, make sure the flat end mill, number of flutes we said was 2. This is going to be a high-speed steel, if I'm not mistaken. Yeah, high-speed steel HSS. And it's going to be 2 flutes upcut. So my diameter in this case is the cutting diameter. So we're going to say 1/8 of an inch. So we'll just say 1/8 of an inch. Our shaft diameter. So when you're clicking here to the left, you'll see the blue arrows here on the right. So diameter is asking about the cutter. The shaft diameter in this case is different. It's 1/4 shank diameter. So we'll show you that's going to be 1/4. And over here is what it's kind of drawing out the tool. Our overall length was the 2 5/8. So we'll go to overall length, say 2 5/8. And then length below the holder, we'll just assume we probably have that checked up pretty good in there. So let's just say 0.75. Whoops. Okay. Our shoulder length, which is basically we'll call that the cutting length. And we'll go here. And the length of cut, I believe that's what LOC is, 3/8 of an inch. So click here and say 3/8 of an inch. And then the flute length, again, is we're just going to say 0.375 or 3/8 of an inch. So there we go. This is basically all you need to do to set the tool up, get the geometry straightened out. And once we're there, then we can go into, if you needed to add a shaft, any type of special holder, but we're going to assume you have a desktop machine and not something that's automatically tool changing, and you don't have a really fancy machine that needs to know exactly what collet is holding it. And that's when you get into more fixtures. If you have to let your tool work around a fixture, you want to, basically try to input as much data as you can so you can see if there's going to be any collisions with any type of work done holding. But if you're a hobbyist like myself, we can skip that. We'll go into here, and this is the cutting data. And this is where you really want to try to focus on what your machine limitations are. For my case, my machine itself, the speed, I believe, is 150 inches per minute, which that's the max the machine will go. Feed rate is what we were talking about. So my machine will max do 150 inches per minute. And if we go back into the Onsrud tools, into the data sheet itself, where it says what type of chip load we are looking for. So we're in the 4100 series. We're using an 1/8 inch bit, so we want our chip load to be 0.004 to 0.006. So that is if you had a purely rigid machine. If you don't have a pure rigid machine, meaning if you have one of those desktop CNCs, play around with these numbers. It's probably going to be half of what these chip loads are, because your machine's going to have some type of deflection. Understand this though, the smaller that you go with the chip load, that means the more your material is using the cutter, which means your cutter then can dull about twice as fast. So just keep that in mind. These are optimal based on a pure, sturdy machine. So if you do have, like in my case, a G0704, most of these chip loads will work, especially if it was a hardwood, for example. So let's go ahead and let's use on the lower end 0.004. So feed per tooth, we're going to say is 0.004. Hit enter. And now what this is going to do is it's basically going to make us kind of play the game. If I wanted a 0.004 based on a RPM of 5,000, the max inches per minute that I can get out of the machine is 40. I can try to play around with this, and this is where the game kind of plays, but we'll change the spindle speed. On my machine, I have a belt drive conversion, so I can do 4,000 is actually my max. And you can see here, based on the chip load, the max speed that I can run this bit is at 32 inches per minute. And that's doing all the calculations that basically are in line. Now these ramp feed rates, these are just going to be conservative feed rates that they have calculated through Fusion 360. So obviously if you're plunging into a material for the first time and you've never done this before, go a little bit slower. Again, it's all about rigidity on your machine, because when you start getting into the smaller bits, like let's say in this case 1/8 of an inch, if it sees any type of deflection that small of a bit, it will snap, and you'll be wasting, in this case, I think it's a $13 end mill. So something to keep in mind. You just want to, obviously take it slow and don't rush your cuts. This is where optimization of your tool paths come into play, trying to make sure you're not cutting over things that have been cut before. But let's say I had a really fancy machine though, and let's say I can get 10,000 RPM, for example. Now you can see how 10,000 RPM has basically jumped the feed rates automatically to about 80 inches per minute, and having a depth, feed cut of 0.004. This is based on that, but we will say disabled for coolant if you had a coolant, and that's about it. That's how I end up programming my Onsrud bit. So let's just put this back down to 4,000 RPM, which is where the max my machine will go, and it'll run at about 32 inches per minute. And we'll leave all the plunge rates and everything because we can mess around with the step down. We could actually say, if we wanted to link the step down here, and this probably is more beneficial if you do it now than later, but I always do it later, but for this purpose we can try to do it now. Your step down per Onsrud is actually saying depth of cut 1 times D, use recommended chip loads. If you want to go 2 times the depth, reduce your chip load by 25%. And if you want to go 3 times your depth, reduce your chip load by 50%. So we're not going to overload this. We'll use 1 times the diameter. So our max depth of cuts that we will use here, so we'll say our step down is 1/8 of an inch. And that will be our max step down. Our step over is going to be how much does the part step over onto the face of the end mill. And step over is normally a fraction of, I've seen anywhere from 1/4 of the diameter to 1/2 of a diameter, but let's see if Onsrud has anything for step over rates. I don't really see anything for step over. So we're just going to take a conservative rate for right now, and we're going to say it's going to be 0.25 times 1/8 of an inch. So our step over, max step over that we're going to use is 0.3125. And that's just going to be a 25% max step over. Go ahead and click OK and accept. And now you can see our tool has been added to the library. And close and go back to our model. Here, we're going to go ahead and we're going to set up a pocket. And in this case, we're going to do 2D adaptive clearing. We're going to click the surface that we want to pocket, which is that. We're going to then pick our tool over here, which was the Onsrud tool we just created in our library. So we'll click there, hit select. Double check our geometry, our heights, a retract height. Now we've had these talks before in my machine. It's basically the retract height is doesn't need to be as high, and we can verify our offsets. So 0.2 of an inch, 0.2 of an inch on the retract height. Top height is going to be 0, and offset off the bottom is going to be 0. Look at our passes again. Optimal load, that's our step over, and our minimum cutting radius is I guess 1/10, or toolpath will have a bend. Oh, I guess we could set this to 0, but this is basically saying for the hard corners, we're not going to get our hard corners. So if you can see here, if you set it to 0, it's going to put the tool as close to that. If you set it to 0.07, then it's going to kind of round the inside. So basically that will affect your fit and finish if you were using this trying to mill out a square hole. But in this case, we're just going to leave it to whatever it defaulted as. We're not going to try to leave any stock this time. We're just going to let it do a full pass. And then we're going to look at linking and just verify everything looks good. Looks like we're going to do a helix type ramp in. And we're going to see how this works. So our total piece is 0.25, which 2D adaptive will go the full depth of the cutter. Same as 3D adaptive, they like to try to use the entire cutting surface. This is a 1/2 inch cut, so we'll just verify in this setup here. Let's click simulate. Let's double check to see what's going on here. You can see a lot of red marks here, and it basically shaft collides with the stock. So because of the depth of cut on this piece, it's actually too shallow. But you can see here now where the side of the bit is actually going to hit the side of the box, and that's where all these red line warnings are coming from here. So we're going to go ahead and pause this and take a look a little bit deeper like we were just saying. But you can see here how the shaft is now interfering with it. So these are warnings that you want to look for when you're doing not just only speeds and feeds, but when you're doing any type of operation. You want to make sure that you can actually achieve the depth that you're looking for. So in this case, I know my platform could only be 3/8 of an inch, so I'm going to raise this up 0.3, click OK. And now when we go back into manufacturing, we'll right click, we'll hit generate on the adaptive toolpath one more time. And it's having a problem, so let's just go in there. Whoops. Go to edit, say yes. Geometry, we're gonna reselect our geometry as the bottom here. And then everything else should have been saved. And now when we go in here, we'll say simulate. I want to see if we can make it so we don't see, there it is. We'll leave the model instead of getting everyone dizzy here. There we go. So you can see the tool's going to go down, and that's probably the most aggressive cut, is that helix getting down in there. I don't like it for like metals per se, because it is a very aggressive type of entrance. So let's go ahead back in here, linking, and let's change it from helix. Let's say there's only a couple options, I guess. Plunge pre-drill, and that's if you pre-drill the hole, which is definitely a possibility. I guess we'll leave helix, and let's reduce the angle, and let's increase the diameter slightly. Our tool is 0.125, so I mean it's going to be taking a pretty deep cut, so that's why it's very important that you try to basically not rush this process, especially if you're going into something and you have a very non-rigid machine. This is normally where the tool will break. So we'll just say okay. And if you can pre-drill a hole, I think it is beneficial to pre-drill a hole if you have the opportunity, if you have a non-rigid machine, for example. Let's generate this one more. Let's simulate this one more time. Go ahead and click play. And that does look like it's a lot better. And everything seems to be working. Now, mind you, this is a lot faster than it's really going to be. In our case, you can see how slow that speed is in normal speed. So we'll speed that up and be done. This is one thing about the corners. Take a look here. You can see how it's two different shades of green. That means that the tool itself is not going to reach into this corner by that much. So make sure that you're okay with that, because it is basically the diameter of your tool. And let's go to statistics. So in this case, to machine this out at that speed and feed with an 1/8 inch tool, it's going to take 5 minutes and 5 seconds to do the full operation of machining. And it's going to be about 12 linear feet of machining distance. That's why your tool is very important to understand, you know, the size of the tool for the job that you're doing. If you can get away with this job being a larger tool, then obviously your machine time is going to be significantly lower. Let's show that for example, but let's show the downside of it. So let's go back into the tool library. We're going to go back into here, and I'm just going to copy this tool and paste that. And what we're going to do is edit this tool, and we're going to call this one the Onsrud, and we're going to change it from the 1/4 inch one, or from the 1/8 inch one. Let's change it to the 1/4 inch Onsrud tool. So 4041, they make a 1/4 inch, 4105 for example. So let's go into 4105. It is a 2 flute, 5/8 of an inch, 1/4 inch diameter, 1/4 inch cutting diameter, overall length 2 3/4. So let's go ahead and change this real quick. The cutting chip load, go double check what the Onsrud says for their cutting chip load. Still the same series, except now it's going to be a 1/4 inch, so we can go up to 0.005 to 0.007. So let's go ahead and change that to 0.007 because it is a larger bit. click off of it. Now you can see the speed has almost doubled to 56 inches per minute at a 4,000 RPM. We'll change this to 0.25, enter, and we'll just leave that at, let's say 0.25 times 0.25. So our step over now is a quarter of the diameter. And with hardwood, hit accept. We're good to go. Close. So let's go back into our adaptive path. You remember that if we go to machine time, just to double check again, it was going to take total time of about 4 minutes 50 seconds machining time. I think the other sheet said about 5 minutes. So just something to keep in mind here. So just remember about 5 minutes. So let's go back to edit. Let's select the new tool. Let's go into our library where we just saved it. Let's use the 1/4 inch tool, select, and then hit OK. And now you can see the tool has changed significantly. The diameter has changed now. So let's go ahead and simulate it real quick here. That was way too fast, so let's go ahead and simulate it again. So again, you can see the shaded area of what's not getting machined based on the tool diameter. So a little bit of the corner is going to be closed off, but let's go over here to statistics and look at the time. Just by upping the thing, it's now almost 240, so it's roughly about half of those 5 minutes just by upping the tool size. So there you go. Hopefully that helps you out and understands a little bit more with tools, speeds, and feeds. When you need to get the tool to move faster, then your machine needs to have a higher RPM. But a lot of the times the higher RPMs, they sometimes lose torque. So sometimes it's a give or take. If you need to machine something out with a very tiny bit, then you definitely need something in the 10,000 to 15,000 RPM range in order to make it viable as not a long time your machine will be running. But if you can do any type of roughing operation with a larger bit, and then you can come back and do the fine tuning with the smaller bit if you needed to get the corners, for example, in this case. Let's go ahead here. Let's do another adaptive clearing. Let's change it to the smaller bit, and let's try to get that to happen. So we're going to use the 1/8 inch bit, and we're going to go into our passes, and we don't want any stock to leave, just like the last one. And we want to try to see, and I don't know where they ended up putting it again, but we want rest, I believe rest machining, and this is going to start from where the other tool could not pick up. Let's make sure our pocket is selected here and click OK. And there you go. So you can run this at 2 minutes and 50 seconds. Swap your tool over real quick and simulate this one. And what that does is that just cleans up the corners. Let's go ahead here and close out that, and let's look at the machine time. And you can see that took 3 seconds to go and do that operation. So instead of waiting 5 minutes to do the whole thing with the smaller bit that you could wear out, eventually cause damage, or ruin a $13-14 bit, you could run a bigger bit, clear out most of the material, come back and catch the fine detail accordingly with the smaller bit, and just with a little bit of tool change, and you're good. So hopefully you learned something today on this video. I really greatly appreciate everyone asking questions in the comments. Keep them coming. It's giving me content for future videos, and hopefully we won't keep doing fishing lures, but that is something that is a hobby of mine and what I like to do on the side, especially in Fusion, creating those models. But anyway, keep the questions coming. Again, I appreciate it. Like and subscribe if you can, and stay tuned for more future videos. Thanks. Have a great day.